Imagine a magnet so powerful it could wipe out technology on Earth from millions of miles away. This isn't science fiction, it's the reality of magnetism in space. In the vast expanse of the universe, magnetism weaves an intricate web of influence that extends far beyond our humble planet. The Sun, our very own star, is a colossal dynamo. Its magnetic field stretches its invisible threads throughout our solar system, influencing everything in its reach. Now you might be thinking, but isn't Earth's magnetic field stronger than the Sun's? And you'd be right, in a way. The magnetic field of the Earth at its surface is about 25 to 65 microteslas. That's quite a bit more than the Sun's magnetic field on the surface, which is only about 1 Gauss or 0.0001 Tesla. But wait, I hear you say, how can the Sun's magnetic field have such a dramatic impact if it's so much weaker than Earth's? Well, dear listener, it's all about size and reach. The Sun is over 100 times the diameter of Earth, and its magnetic field extends billions of kilometers into space. This means that even though the Sun's magnetic field is weaker at its surface, its total magnetic field, or magnetic flux, is incredibly powerful. It's like comparing a small but strong magnet to a massive but weak one. The smaller magnet might have a stronger field at its surface, but the larger magnet's field can reach much further. You see, the Sun's magnetic field is like a giant bar magnet embedded in the solar wind, a stream of charged particles constantly blowing out from the Sun. This solar wind carries the Sun's magnetic field out into space, where it interacts with everything it encounters, from other stars to distant galaxies. So the Sun's magnetic field, while seemingly weak, plays an enormous role in our solar system, but that's just the beginning of our magnetic journey. Now let's take a trip away from our Sun and venture into the world of magnetars. Neutron stars with magnetic fields up to 1,000 trillion times stronger than Earth's. Magnetars are the celestial rock stars of the universe. They're the remnants of supernovae, the cataclysmic explosions that mark the end of a star's life cycle. After such a dramatic event, what's left is a super-dense core, a neutron star. Among these neutron stars, about 10% morph into a different kind of beast altogether, a magnetar. Picture this, a magnetar is a city-sized star packed with more mass than our Sun. It's so dense, in fact, that a teaspoon of its matter would weigh as much as a mountain. But it's not just the density that blows minds, it's the magnetic field. A magnetar's magnetic field is a force to be reckoned with. We're talking about a magnetic field that reaches up to a staggering 10 to the power of 11 Teslas. To put that into perspective, that's 1,000 trillion times stronger than the magnetic field we experience here on Earth. So, what's the role of these magnetic monstrosities in space? Well, their intense magnetic fields generate powerful bursts of gamma rays and X-rays. These energy bursts can be detected by our space telescopes, helping us map the universe and understand more about these celestial heavyweights. But it's not all about the big bangs. When a magnetar's magnetic field changes, it can cause starquakes. Yes, that's right, quakes on a star. These starquakes can release more energy in 1/10 of a second than our Sun does in 100,000 years. Magnetars are truly nature's ultimate magnets. They're the most magnetic objects in the universe, and their role within it is as fascinating as it is formidable. These cosmic powerhouses provide a glimpse into the extreme conditions and forces at play in the universe, pushing our understanding of physics to its limits. Magnetars, nature's ultimate magnets, are truly awe-inspiring, but what about the space between stars and galaxies? As we venture further into the cosmos, we encounter a phenomenon that might surprise you: intergalactic magnetic fields. Now, when you think about space, you probably imagine it as a vast, empty void, devoid of anything substantial. But let's shatter that illusion with a fascinating revelation. Even in these seemingly barren expanses, there exists a magnetic presence. Let's talk about the magnetic fields that exist in the voids between galaxies. These fields are incredibly weak, often less than 1/10 of a nanotesla. To put that into perspective, the Earth's magnetic field is about 50 million times stronger. But don't let their weakness fool you. These intergalactic magnetic fields cover enormous regions stretching across the vast emptiness between galaxies, and they play a significant role in the cosmic structure formation. Now, you may be wondering, how do these weak magnetic fields influence the universe's structure? Well, these fields are believed to affect the movement and distribution of charged particles throughout the cosmos. They can redirect high-energy particles like cosmic rays, influencing where and how galaxies form. Moreover, they're thought to play a crucial role in the early universe, shaping the cosmic web of galaxies we see today. The existence of these intergalactic magnetic fields is still a mystery that scientists are trying to unravel. How did they form? How have they evolved over billions of years? These are questions that continue to intrigue astrophysicists and fuel ongoing research. The discovery of intergalactic magnetic fields has opened a new chapter in our understanding of the universe. It has shown us that even in the seemingly empty stretches of intergalactic space, there's more than meets the eye. So the next time you gaze up at the night sky, remember this: there's more to the universe than stars and galaxies. There are invisible forces at work, shaping the cosmos in ways we're only beginning to understand. Even in the vast emptiness of intergalactic space, magnetism plays a role. But what about the grandest scale of all, the entire universe? Now hold on to your seats as we zoom out to the largest scale possible: the entire universe. Magnetism is not just confined to our planet or even our solar system. It spans across the cosmos, influencing the arrangement and behavior of celestial bodies on a grand scale. One might wonder, just how magnetic is the universe? Well, current estimates suggest that the average magnetic field in the universe is about 1/1000th of a Tesla. That's a minuscule fraction, but remember, we're talking about the entire universe here. Now let's delve into the concept of a universal magnetic field. Some theories propose that a magnetic field permeates the entirety of the cosmos. This is not as far-fetched as it sounds. After all, we know that magnetic fields are produced by moving charges, and the universe is teeming with charged particles. In the early universe, just moments after the Big Bang, charged particles were zipping around at near light speeds. As these particles moved, they would have created magnetic fields. This is the seed field theory, suggesting that these primordial magnetic fields could have grown over time to become the cosmic magnetic fields we observe today. But the plot thickens. Some scientists hypothesize that these fields could have an even more profound impact. They could influence the process of galaxy formation, dictating the shape and orientation of galaxies. They could also play a role in the propagation of cosmic rays, high-energy particles that zoom through space. In essence, the magnetic field could be the unseen puppeteer, pulling the strings of the universe. It's like the director of a grand cosmic ballet, choreographing the dance of galaxies and stars. So what does this all mean? It means that magnetism, a force we interact with daily, has implications far beyond our immediate surroundings. It's a universal phenomenon that shapes not just our world, but the entire cosmos. From the smallest scales to the largest, magnetism plays a critical role. It's not just about sticking notes to your fridge, it's a fundamental force that shapes the universe. In our journey, we've seen how magnetism works on a cosmic scale, from the heart of our sun to the furthest reaches of the universe. It's a force that shapes galaxies, fuels stars, and even guides life on Earth. Magnetism, this invisible yet mighty force, plays a central role in the grand orchestra of the cosmos. From magnetars, the universe's most magnetic objects, with a strength 1,000,000 billion times greater than Earth's, to the intergalactic magnetic fields that stretch across millions of light years, magnetism is undeniably a universal powerhouse. It's responsible for the sun's scorching corona, the auroras that light up our polar skies, and even the very existence of our planet. This unseen force, often overlooked in our daily lives, is a fundamental part of the intricate dance of the cosmos, influencing everything from the tiniest particles to the largest galaxies. So there you have it. Magnetism, a force we interact with every day, is also a key player in the grand ballet of the cosmos. It's a reminder that we're all part of this vast, interconnected universe. And if you liked this explainer, we believe you would also enjoy the video shown on your screen right now. Click on it and let's catch up there.